Okay, welcome to another edition of Algebra 1. Today's episode, Section 1.4, the distributive property. And on today's episode, we are going to use the distributive property to evaluate and simplify expressions. So we'll kind of talk about what that means. All right, distributive property. And I'm sure a lot of you guys have seen this in the past, but we're going to do it again. And so if you haven't seen it or weren't very good at it, here's another chance to get caught up. So what is the distributive property? Distributive property is when we multiply a term through parentheses, and we're doing this to simplify. So again, the objective was to evaluate and simplify. We're doing this. We're going to multiply through parentheses to simplify. The big thing is we have to watch out for negatives here because it is the sum. It's the sum that we're dealing with. So negatives can be a little tricky because sum means addition. Here is it with letters. A times the parenthesis of B plus C. So you can use parentheses, or you can say A times the quantity of B plus C equals AB plus AC. And again, just pointing out that these are plus signs, so we're talking the sum. So we have to watch out for negatives. So an example, and I'll give you an example with a negative just so we can throw that in there. But we've got, say, a negative 3 times, in parentheses, x plus 7. Okay, so according to what our distributive property tells us to do, it just takes the number outside the parenthesis and multiply it through both numbers of the parenthesis. So negative 3 times x would give us a negative 3x. And then the second number, negative 3 times 7, would give us a negative 21. And you could be done there. You could be done there. Again, we talk about it being the sum, because technically this would be a negative 3x plus a negative 21, but no one really writes it with the plus negative in here, so we can just go ahead and use this version right here. So that's your distributive property. So let's go ahead and just do number 2 for practice. And I only want to do number 2 because I think you're good with this. But number 2 is written tricky, and I did it on purpose just to show you can distribute with the parenthesis first, and then the number behind it. So it's the same steps, same process. So you're going to take that 4, and you're going to multiply it through each number in the parentheses. So the first one will be 4 times 6x squared. Well, 4 times 6 is 24, and then x squared would be x squared. Then we're going to take the 4 and multiply it by the negative x here, which would give us a negative 4x. And then finally, the last number, the 4 times the negative 3, gives us a negative 12. And there we did it. We distributed. So you can work on 1 and 3 if you need more practice with the distributive property. The next set of problems says let's just use the distributive property with mental math. And I highlighted mental math because that means we're going to use no calculator. No calculator. Okay? Look at problem number 4 here. Sure, if you can punch in your calculator 15 times 99, that's all great. But that's not what we're looking for here. If it says to use mental math, it wants you to use no calculator. So we're taking a look, and it says use the distributive property to rewrite each expression, then evaluate it. So we have to rewrite it. So we take a look at these numbers, 15 and 99. Well, what's a number that 99 is really close to that's a little bit easier to work with? Well, 100. 100 is really close to 99. So I could rewrite this expression by bringing this 15 down and then multiplying it by 100 minus 1. Because isn't 100 minus 1 basically 99? So I'm just taking that there, and I'm just bringing this 15 down here. It's the same problem. I'm just rewriting it. Instead of putting 99, I'm putting 100 minus 1. So now I can do the distributive property. I'm going to take this 15 times 100, which should be a little bit easier for us, 1500. And then we've got a 15 times a negative 1, which would be a negative 15. Now we should be able to do some mental math here, still not using a calculator, and just taking 15 away to get 1485. Okay, let's look at the second one, or the number 5 here. Number 5. Okay, on number 5, you've got 44 times 2.5. Well, we can rewrite, let's just bring that 44 down and make it 44 again. And we can rewrite this 2.5 and make it 2 plus 1/2. So basically what I'm doing is I'm either adding or subtracting to get a number that we're talking about here. So 2 and 1/2, that's saying 2 plus 1/2. Where in number 4 here, we had 99 and we used 100 minus 1. So now let's use the distributive property here. 44 times 2 is going to be an 88. And then a 44 times 1/2 is going to give us 22. Cutting it in half. And now you might have to do a little extra thinking here to figure this one out, but you should end up with 110 for your final answer here. Okay, so when we look at this one, you're basically breaking down numbers and adding and subtracting. For number 4, with that 99, you could have gone, you could have gone, say, if it was, you could have used addition there if you wanted to go, if you wanted to use that 100, you could use 100 plus 1, or you could go, in this case, you can always subtract. What you want to do is rewrite the number and then add or subtract one way or the other. Okay, for example, number 6, you could change that 49 to a 50 and go 49 plus 1. That might help you out there. To deal with 50 is a little bit easier to work with than the 49. So you could rewrite that as maybe 7 times 50 minus 1. Okay, that might make it a little bit easier to deal with when you're multiplying by 50s. So you're trying to change one number with an addition or subtraction to something that's easier to work with. And again, using mental math with no calculator. All right, some more terms here. Let's talk what are like terms. Like terms are terms that contain the same variables and exponents. We're talking the exact same variables and exponents. So if I give you an example here of, let's say, 5x squared plus x plus 3x squared plus 7x. So in this case, we're looking for terms that have the exact same variable and the exact same exponents. So in this case here, we have a couple of those. First, we've got this 5x squared, and we've got a 3x squared. They have the same variable, x, and the same exponent, x squared. Okay? So what we're going to do there is add those up. And these numbers in front are called coefficients. We'll get to those further down. But 5 plus 3 is 8. So how many x squareds do we have? We have 8 of them, 8x squared. Now again, we also have another term here with an x and then an x. They have the same variable, same exponent because it would be a 1. And so now we got 7x, and hopefully we're sly enough to know that if there's not a number in front of it, it's a 1. So now we've got a 1x plus a 7x would give us an 8x. So in that case, what we're doing is we're combining like terms. It helps us to simplify. Simplest form, when we've finished simplifying it, it's an expression that has no like terms and no parentheses. It's in its simplest form. There's no other further things we can do with it. It's in its simplest form. No like terms and no parentheses in there. We're using distributive with the parentheses, and we're combining like terms with the like terms. I don't think we need an example for that one. Coefficient. That's the number or the number term in front of a variable. So in this above example, 5 would be a coefficient in front of the x squared. 1 would be the coefficient in front of this x. We've got a 3 as a coefficient and a 7 as a coefficient. That's the number in front of the variable. So in an example here, if we use, say, 8y plus 1y, these are your coefficients. 8 is a coefficient, and so is 1 is a coefficient. Those are the numbers in front of the variable. And then we get it into, when we combine like terms here, we get 9y. 9y, and here's your example of simplest form, because now there's no like terms, because we combine them to get 9y. And then we also have another example that this is our new coefficient. So combining like terms. All right, more practice here. And this one says rewrite the expression using the distributive property, and then we want to simplify. So let's just go over to number 9 here. We're going to rewrite it using the distributive property and then simplify. So we're going to use distributive, and then we're going to make sure we don't have any like terms. We can get it in simplest form. Okay, so let's just do number 9, and you can work on 7 and 8 on your own. But number 9, let's go 3 times 4x distributing gives us a 12x. And then a 3 times the negative x gives us negative 3x. And so now we've done the distributive property, and now all we have to do is combine like terms. Well, we have a 12x and a 3x, so we have the same variable, so they're like terms. So we just have to subtract their coefficients. 12 minus 3 is 9x. And there's our final answer in simplest form. These next set of problems here says simplify each expression. If it's not possible, then go ahead and write not possible. Okay? So let's simplify each expression, and let's go ahead and look at number 15 first. Okay, let's look at number 15 all the way over here. So we're trying to simplify it. We do have parentheses, so we're actually going to go ahead and distribute. So negative 3c times 4 would give us a negative 12c. And then we've got a negative 3 times a negative 6. Well, a negative times a negative is a positive. So negative 12c plus 18. And that would be in simplest forms because we have no parentheses and we have no like variables. And if we take a look, say, at number 12, and if you take a look at number 12, just remember you can do this. It's just kind of written backwards here, where you're going to go with the 7 times the 2g and then the 7 times the negative 6, and you can still get your answer there. Okay? All right. Next, we're almost done. Just a couple problems for you to work on here. Write an algebraic expression for the verbal expression. So they're going to give you words here. We did this the other day. And we're going to write an algebraic expression for these. Twice the difference of 3x and y increased by 5 times the sum of x and 2y. And then in letter B, we're talking about simplifying the expression and then indicate the properties used. So we're using this, and then we're going to simplify it. And again, we're asking you to indicate the properties that we're using. Okay? So let's take a look at that first part. The 3x and y, it says twice the difference. Well, difference is a subtraction problem. So we've got 3x and y that we're subtracting, 3x minus y. We're going to put those in parentheses because it says twice that. So twice means to multiply by 2. And now we've got another part here where it says increased by, which should be a keyword for add, 5 times the sum of x and 2y. So again, I'm going to use the sum as an addition, and x and 2y are going to go in parentheses here. X plus 2y, and then it says 5 times, so I got to multiply that by a 5. So that's kind of what we're going to do there. And then in part B, we're actually going to simplify this and then identify the properties that you use. So we're going to have to distribute. That's a hint. That's one of them. And then go from there and combine like terms. All right, lesson summary here. Explain how to combine like terms. Just explain what you do in the box. And your practice problem is to simplify this problem here, this expression. And it doesn't tell you to write the properties used, so just make sure we simplify it. And remember, simplify means use distributive property and combine like terms. So no parentheses left over and no like terms without combining them. Okay, so that is the distributive property, section 1.4. Hope you enjoyed it. Bring any questions you got with us for tomorrow.